Before we delve into the statement, it's important to first understand what molecular fuel petals actually are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring composed of superconducting magnets. It is the largest and most remarkable atom smasher in the world, representing the pinnacle of human achievement. In fact, it is so powerful that it can recreate the exact conditions of the universe's first moments. However, could the machine that aims to solve the puzzles of the universe potentially hold the key to something truly unique? Founded in 1954, CERN is one of the most renowned research institutions worldwide. With 23 member countries and numerous scientists, it serves as a hub for collaboration and innovation. While the LHC is CERN's primary undertaking, it is only a portion of a vast network of fuel petals and experimental studies. This infrastructure is designed not for motors or humans but for subatomic particles, in a test of endurance and the very fabric of space itself. The LHC accelerates protons close to the speed of light, steering them into a collision course that mirrors the energy released during the Big Bang. These collisions generate temperatures far hotter than the Sun's core. A vast array of magnets directs the protons on their route, while advanced cooling systems maintain the magnets at temperatures colder than space. Beams in the LHC are made to collide at 4 distinct locations across the accelerator ring, interacting with 4 specific particle detectors: ATLAS, CMS, ALICE, and LHCb. Each has its own distinct function, studying different facets of particle physics. Together, they act as enormous cameras, capturing images of these collisions. Scientists then analyze the resulting particles, searching for signs of the elusive Higgs boson, also known as the God particle, and other anomalies that might shed light on the fundamental components of the universe. By focusing on the microscopic, we unlock insights into the macrocosmic world. But with each answer, new questions arise. With every discovery, a new challenge surfaces. The LHC isn't just a scientific tool, it is a symbol of human curiosity and progress. It represents our relentless pursuit of understanding and our desire to unlock the fundamental forces that control our universe. But as we push the limits of our knowledge, we must also confront deeper existential questions. What risks lie in probing the unknown? Could our quest for knowledge inadvertently unleash powers beyond our control? Inside CERN, where the boundaries of human understanding are constantly expanded, a chilling revelation has surfaced, causing even the most experienced scientists to pause. Brian Cox, a former CERN scientist and an authoritative voice in the realm of particle physics, recently shared a statement that has both captivated and unsettled the world. His words echoed with unsettling clarity. The purpose of CERN's LHC is to simulate a mini Big Bang. Yes, you heard correctly, a miniature version of the very event that birthed our universe. The physicist elaborated on the implications of this objective, highlighting the LHC's immense potential to make groundbreaking discoveries, including uncovering the secrets of the Higgs boson and delving into the mysterious realm of dark matter, which constitutes a large portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very essence of the universe. It's an alluring possibility but one fraught with peril. The mini Big Bang is not just a theoretical concept, it is an observable reality at the LHC. The extreme temperatures, pressures, and raw energy simulate the conditions present at the dawn of time, when the universe was created. We are standing on the brink of recorded history, witnessing the inception of existence itself. But with such power comes great responsibility, and the pressing concern of what if something goes wrong. In fact, something did go wrong. Anatoly Bugorsky, a Russian physicist, experienced an accident in 1978 that would forever alter his life. While working at the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a malfunction caused a proton beam to strike him. The beam, carrying an unimaginable force, entered the back of his head and exited through his nose. His experience was terrifying. He saw a flash brighter than 1,000 suns yet felt no immediate pain. The proton's path left behind a trail of destruction, burning tissue and bone. Yet, astonishingly, he remained conscious and even walked to seek treatment. The outcome was unsettling yet surreal. The proton beam caused localized tissue damage, leading to partial hearing loss in one ear and facial paralysis on one side. Remarkably, Bugorsky's cognitive functions remained unaffected, and he continued his career in medicine. This incident serves as a stark reminder of the immense power and potential dangers inherent in particle accelerators. The risks associated with machines like the LHC ought not to be undervalued. The possibility of catastrophic reactions, where the very fabric of life is altered, is not the stuff of science fiction. It is a real concern, voiced by esteemed scientists. One of the most unnerving and fascinating issues surrounding the LHC's experiments is the potential creation of a miniature black hole. Black holes are regions in space where gravity is so intense that even light cannot escape. These cosmic vacuum cleaners devour stars and remain mysterious entities hidden in the shadows of our universe. Could the LHC generate one of these phenomena, even on a small scale? Could this black hole grow uncontrollably and consume the Earth from within? Scientists have reassured the public that any black hole generated by the LHC would be unstable and would disappear almost immediately. Still, the possibility of such an occurrence has sparked debates, fears, and wonder at the power humanity wields. It's important to understand how the LHC could create a black hole. The answer lies in the basic mechanics of particle accelerators. When protons collide at near light speed, the energy produced is so vast that it distorts the very fabric of spacetime. Imagine a trampoline stretched taut, and then a heavy object is dropped onto it. The fabric bends, and if the object is sufficiently heavy, it creates a well deep enough to draw anything nearby into it. This serves as an illustration of the possibilities inside the LHC. Within the realm of quantum physics, where the laws of the universe are often strange and awe-inspiring, a hypothesis suggests that there could be more dimensions hidden within our reality. If these dimensions do exist, the LHC's experiments might tap into them, creating a gravitational well that forms a small black hole. This bizarre interaction of particles has even caught the attention of well-known scientists, such as the late Stephen Hawking. In his writings, Hawking raised the possibility of the Higgs boson at extremely high energy levels, leading to a catastrophic event known as vacuum decay, an event that wouldn't just destroy the Earth but could potentially erase the entire universe. The renowned cosmologist Sir Martin Rees has also voiced concerns about CERN's experiments. In his book, Our Final Hour, he explored the risks associated with particle accelerators, including disastrous phase transitions that could ripple through spacetime. Though Rees assigned a low probability to these catastrophic outcomes, he argued that even a small risk deserved serious consideration. Brian Cox himself has acknowledged these concerns, reassuring the public that the LHC operates under strict safety measures and that the risk of catastrophic scenarios is nearly non-existent. He emphasized that while the theories surrounding black holes, extra dimensions, and vacuum decay are intriguing, they remain largely speculative and unproven in the real-world context of particle physics. Still, the sheer scale of what is being attempted at CERN leaves room for both awe and apprehension. Even if the immediate risks seem minimal, the broader implications of tampering with fundamental forces remain an open-ended question. What if there are unknown variables? Could we be triggering processes beyond our current understanding? This brings us to a deeper philosophical dilemma: should humanity pursue knowledge at any cost? History is filled with examples of scientific breakthroughs that have led to unintended consequences. The splitting of the atom led to nuclear energy, but also to nuclear weapons. Genetic modification has given us revolutionary medical treatments, but has also sparked ethical debates. What if our exploration of particle physics leads us into territory we cannot control? Some theorists speculate that if we were ever to accidentally breach a hidden fundamental law of the universe, the results could be instantaneous and irreversible. Others argue that even if the risks are incredibly small, the magnitude of the consequences means we must approach these experiments with the utmost caution. CERN scientists maintain that they are fully aware of these concerns and that safety is their top priority. However, as history has shown, science is not always predictable. The pursuit of knowledge often carries unforeseen dangers. Yet, despite these fears, the LHC remains a beacon of human ingenuity. It is a monument to our insatiable curiosity, our drive to unravel the deepest mysteries of the cosmos. The discoveries made at CERN could reshape our understanding of reality itself, unlocking new realms of physics, revealing the true nature of dark matter, and perhaps even offering glimpses into the very origins of existence. The public knows that the involved energies are well within what the Earth naturally experiences, and the chances of creating a stable black hole are astronomically low. Even if a black hole were created, scientists argue it would be so tiny and volatile that it would quickly dissipate, releasing energy in a phenomenon known as Hawking radiation. It would be a brief moment of cosmic wonder, a fleeting glimpse into the void before it vanished forever. Some have taken this concept further, speculating that the LHC's experiments may provide a pathway to another universe or dimension. While this theory is largely dismissed by the scientific community, it has captured the imagination of many, becoming a topic of fascination, fear, and myth. What might lie beyond our universe? Could we unknowingly unleash forces or entities we do not yet understand? The notion of opening a portal to another realm has even been sensationalized by various media outlets, fueling uncertainties and fears. But where did this idea originate, and what does it mean in terms of scientific understanding? The concept of hidden dimensions is not new to physics. String theory, a leading contender for a unified theory of everything, suggests there may be more dimensions than the usual 3 of space and 1 of time. These extra dimensions could be compact or hidden from our perception. However, under extreme conditions, they might become accessible. Now, consider the LHC as a massive key unlocking doors that have been closed since the beginning of time. When protons collide at energy levels never before achieved on Earth, in theory, they could cause ripples that probe these hidden dimensions. If these dimensions exist, the LHC may uncover them. Yet, before we get too excited with wild theories, it's important to recognize that, while the LHC is immensely powerful, there is no definitive evidence suggesting it will open a door to another universe, or, as some fear, to hell itself. Still, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that these ideas will continue to captivate our collective imagination. Should we be concerned about the LHC and its potential risks? It's easy to be swept up in sensational headlines and fears of global catastrophe. However, the truth is that scientists at CERN are acutely aware of the dangers involved. They've done everything in their power to ensure their experiments are safe, continuing to monitor and test their work with the utmost care. The potential rewards of their research, such as breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly remarkable. The LHC not only showcases human ingenuity but also offers a glimpse into the very heart of the universe. However, as with any major scientific advancement, the risks should not be ignored. We must approach these discoveries with a balance of awe, respect, and caution. The Large Hadron Collider represents the frontier where theoretical inquiry meets experimental reality. Its true potential to answer fundamental questions, such as the origins of mass and the nature of dark matter, is immense. Yet, despite rigorous safety measures and extensive simulations, the LHC continues to inspire a sense of mystery and trepidation in some. The sheer scale of the machine and the energy it generates are awe-inspiring, and each new experiment opens doors to uncharted scientific territories. While most scientists remain confident in the safety of LHC experiments, there will always be fundamental uncertainties. What if unexpected anomalies emerge that challenge our understanding of physics and the universe itself? The LHC is pushing the limits of human knowledge and testing how much control we truly have over the natural world. As particle collisions simulate conditions from the earliest moments of the universe, existential questions about their impact on the fabric of reality grow ever more pressing. The ongoing experiments at the LHC continue to challenge the boundaries of human knowledge. While the insights they may yield could dramatically expand our understanding of the universe, there's an undeniable tension between the quest for discovery and the potential dangers that come with pushing the limits of science. As scientists delve deeper into the mysteries of particle physics, they risk uncovering truths that could alter our very perception of reality. The possibility of unraveling new dimensions, detecting exotic particles, or unlocking the secrets of dark matter presents immense opportunities, but also potentially uncharted risks. Could the experiments at the LHC result in consequences that we cannot foresee or control? The public's fascination with the LHC frequently centers on its potential to cause cataclysmic events or to uncover secrets that could reshape humanity's place in the universe. However, this fascination should not overshadow the careful, meticulous work done by the scientists involved. Despite the risks that accompany high-energy particle collisions, the safety protocols in place are designed to minimize potential hazards. Scientists involved in LHC experiments undergo rigorous training, and the collider's operations are monitored and reviewed at every step. Yet, the sheer scale of these experiments and their implications frequently lead to speculation that extends beyond science into the realm of myth and conjecture. While sensational ideas of alternate dimensions or other universes may fuel media narratives, it's important to note that there is no concrete proof to suggest the LHC will open these theoretical gateways. Though some theories propose the possibility of multiple dimensions, these ideas remain speculative, and the LHC has yet to provide definitive proof of unlocking such mysteries. The LHC's purpose is not to prove these theories but to explore the basic building blocks of reality. Despite intense scrutiny from both the scientific community and the public, it remains one of the most advanced tools available for understanding the universe at its most fundamental level. The collider's potential to answer deep, unanswered questions about the origins of matter and the forces that shape the cosmos is unmatched. These breakthroughs could lead to technological advancements, medical discoveries, and a deeper understanding of the universe, possibilities we can barely imagine. Yet, as we push the boundaries of what is possible, we must also consider the ethical and philosophical implications of such advancements. Are we truly prepared for the knowledge we seek? If the LHC were to reveal hidden dimensions or undiscovered forces, how would that change our understanding of reality? Would humanity be ready to confront such revelations, or would they challenge our existing beliefs in ways we cannot yet anticipate? Throughout history, every major scientific breakthrough has been met with a mix of excitement and apprehension. The discovery of quantum mechanics, the theory of relativity, and even the splitting of the atom all transformed our perception of the universe. But with each new discovery came unforeseen consequences, both incredible advancements and potential dangers. The LHC is no exception. Some theorists speculate that high-energy collisions could produce particles or phenomena we have never encountered before, potentially reshaping physics as we know it. Could there be a fundamental flaw in our current models of reality that only an experiment of this magnitude can reveal? And if so, would we have the means to understand, control, or harness whatever emerges from the depths of particle interactions? While mainstream physics assures us that catastrophic scenarios are unlikely, the mere act of questioning the unknown fuels speculation. Many fear what they do not understand, and the LHC, operating at the limits of human knowledge, naturally becomes a focal point for both scientific curiosity and existential anxiety. Beyond the fears and speculations, one fact remains. The LHC is a testament to human ambition, ingenuity, and our relentless pursuit of knowledge. It represents a global collaboration of scientists, engineers, and visionaries working together to unravel the mysteries of the universe. If history has shown us anything, it is that the pursuit of knowledge always comes with risks, but it is also the key to progress. The discoveries made at the LHC may not open a portal to another dimension, but they may very well open a new chapter in our understanding of the cosmos. And whether the answers it provides confirm our theories or challenge them, one thing is certain: the search for truth will continue, pushing us ever closer to unlocking the deepest secrets of existence itself.